Thanks for coming. My name is Brian Gormley. I'm a professional lecturer here at Marist College. Is my volume okay for everyone in the back?
Excuse me, I don't hear you.
You don't, oh, sorry, I'll talk up. A professional lecturer here at Marist. I've been a software engineer by trade, and I've always worked kind of close to the hardware. So I worked a lot in early mobile days, creating mobile applications. I worked using Bluetooth technologies to do indoor localization by triangulating off of the Bluetooth signal. I work a lot with robotics and sensors and everything that goes along with it. So I'm very much love that intersection of where software really does meet hardware. So IoT is fascinating for me because you are very much right at that level of the embedded area. Brendan Kelly here is a student here at Marist who's working with me this summer on this research. And the idea of this talk is really to get some feedback. This is an idea that I'm playing with at a very early stage, and I'll describe why this thing is kind of gotten my attention in my mind and what I hope to kind of bring it to. But I'd really like to get your feedback too. So as this progresses, please ask questions, stop me at any time. Any comments are welcome. When we look at how we interact with computers, we generally categorize that as input or output, and we describe it with a science called human-computer interaction. And it's very well documented when we look at ourselves and the computers and how we talk to computers. There's a lot of research on this. We've gone through major iterations of it. We've moved from everything from just command line based to GUI, and then we mobile, and now maybe augmented reality might be the next step. Every time we do this, it's a big progression. It's kind of a wave of change that affects how we use computers, and it's a big change for us, the users. But one area that we don't really think about a lot is how computers interact. And as things get smaller with IoT, this becomes a lot more important because the conversations are more and more directly between the computers. We think about this in terms of APIs and things that are at very high levels of abstraction, but yet in IoT, we don't always have those levels of abstraction, right? Because we're talking about small embedded devices. They're supposed to be inexpensive. They're supposed to use less power. They're supposed to be small. So we don't necessarily want to build this big monolithic hierarchy of different tiers. We want to keep things small, which kind of brings us to this. This is the onion, the kind of way we conceptualize abstraction in computing. And again, for IoT, we don't want a big onion. We don't want our ogre here to have all his layers. We want as few layers as possible because we got to keep this thing small and adapted. But one of the problems we run into is that we lose a lot there, like an operating system. Generally speaking, IoT devices aren't going to have one. And that means that whatever software is delivered on that thing, unless there's a cloud mechanism to keep it updated or change it or flash it, is going to be the software that thing is going to run from now until the day it stops running. And the doorbell on my door may only ever get updated, if ever, once. And eventually it might fall out of support, or the APIs it calls in the cloud might no longer exist. And this $200 doorbell that otherwise has a functioning camera and button and useful hardware might no longer be useful, right? Because it's built into a proprietary system that is designed around the whole ecosystem. And it has to be at this point because we need it to stay small. We need it to be inexpensive, right? We can't put that whole onion on the doorbell. The doorbell will cost way too much. No one will ever want to buy it. And if we consider software layers on top of this, on our more standard computing system, things get even worse, right? This is now a situation where when we're designing software for a server side or even a desktop application, we do even more abstraction. And these are things that we just don't have available to us, and we don't necessarily want to have available to us in IoT. So we're moving from a world today where more evolved versions of this, but we're moving away from an area like this where the onion worked really well, and we're moving to an area more like these two, where we have mobile devices. These mobile devices, while they're general purpose in nature, I kind of refer to them as single application focused. The user is focused on the thing they're doing. There's usually some give and ultimately how general purpose they are, and we give up some of that for mobility, and that's okay. In IoT, we take that yet to a new level, right? Our Nest thermostat is really just a thermostat. It's not intended to be anything but we don't get to choose what software we put on this thermostat, right? It's delivered to us by Nest, and there's really nothing we can do to alter that. So what I'm interested in doing is seeing, is there a way to efficiently abstract where we can separate out the software and hardware for these devices, just like we do over there, but not make these a giant onion of abstraction that makes it just too expensive to use, right? There's no point if I have to have a 2 gigahertz processor and 8 gigs of RAM running my thermostat. That's not gonna work, right? So that's kind of the thought process that led me down this road. Is there an opportunity to get there? Because right now, where we are is we have this ecosystem world, right? So for me, it's Google at my home. I have a Nest doorbell, I have Nest security cameras, I have about 6 Google Homes, I have a Chromecast on every TV, and when I'm sitting at my desk chair, I can say, I don't want to say hey Google because I'm scared every phone will light up in the room. I can say, hey Google, show the front door in the office, and the video stream from my Nest doorbell will show on my TV because I have Chromecast hooked up to it. And all this works excellent because it's all Google. But if I took that Google Home and I replaced it with an Alexa, the whole thing just fell apart, right? Maybe I could get cool and I could create a if this then that for it. And I could, maybe do some other weird integration points, but it's all things that I, the user, would have to add on top and figure out a way to do on my own because I'm outside the ecosystem, right? So this is kind of the world that we've created, and to be fair, what other choice did we have? We couldn't put the entire onion on these devices, right? So what can we do? What can we do to kind of get back to that point? So my personal thinking is leading me down the idea of, well, what do all interactions that we share with computers have in common? And the answer for me is that they're all input and output. So if we can figure out a way to semantically describe the input and output, a way to take out the nuance of the implementation and just express the intent, then we could communicate those things between devices. Now, if anyone here is programmed on mobile, there are similar concepts for this. So Android, for example, in their APIs have intents. An intent in the Android API means that my third-party software can intend to send some kind of message to the user through another application, or use some resource on that phone that the user might have designated be used and managed by another application. So I can create an intent in that ecosystem and send it. But if we think more broadly than that, we can describe everything that we do with a computer, every interaction that we have for us and a computer and between two computers as an intent. Now, how that intent is handled is specifically up to that piece of hardware, right? So let's kind of think through just what all programmers start with, right? Like a hello world. If I were to create a hello world message and send it to these 3 devices, they could take that same interaction and interpret the intent of it 3 different ways, right? The phone could display the message as hello world. The smart speaker could say it out loud. And the Braille device here could manipulate its surface so that a reader of Braille can read hello world. It isn't my worry as the creator of the service how that intent was meant to be implemented. That's the device's worry, right? All I have to do is standardize on the message. And to do that, we need to just have a mechanism, which I'm kind of playing with the idea at this point of a protocol, that would enable us to semantically describe all types of input and output. So that's the goal of what we're doing. Brendan here has been working on a couple of prototypes, actually with a couple of other students that were working on these as well last semester with me. And he's going to go ahead and try to activate them. Basically, we have one here. This one is going to play a message as Morse code, literally in just dots and dashes that it's going to say out loud. And this one is going to show the message on the screen. It's just going to be a standard hello world message. I apologize, this room, I'm used to speaking in the rooms that have the little projector here, so I envision having it here so you could see it. But he's going to try to send the message. You might hear the dots and dashes, and if you're curious to see them, he'd be happy to show them off to you at the end too. So I see them flashing, so we'll just kind of work through it. Hear it, kind of. But you get the idea. And this is something that I think the hard part is the categorization, right? It's the ontology of how we decide to categorize those things. But at first, in theory at least, the idea is relatively simple. It's just abstracting out what we want to happen from how it actually happens. We leave the how to the device, and we leave the what to the service. So PSYOP is just the name I'm giving this protocol at this point. It's a hypothetical protocol. There's no white paper for it or legitimate spec sheet yet. That's something that I'm working on now. But the first order of duty then is to define how could we categorize these interactions. And I worked with a student last semester, and I'll kind of get to that in a moment, but I want to just kind of play out another example here of how this could work in the real world, just using the example I gave before. So in my own example of the Nest camera and talking to my home smart speaker and the TV, if we imagine that same scenario, but this time abstracting using PSYOP, we could have a video camera that is sending PSYOP-based messages to its cloud service, just like that camera does today, just not using PSYOP, they're using their own proprietary APIs. And then once that cloud service chews on that information and sees that, hey, I see a zombie here, it could then create another PSYOP message. Again, same message, formatted the same way to send to 3 different devices. Now, how the hardware and software is linked, I'm going to talk a little bit more about that later. Basically, think of it as like a marketplace where the user says, I have this software and I have access to these pieces of hardware. The software says, I have these interaction points. I collect video feeds. I send messages to the user. And you can hook up the hardware that you have that's compatible. And I'll talk more about the details of that in a moment. But the cloud service, recognizing that it sees the zombie, then sends 3 identical messages to 3 different devices that the user has hooked up. Their phone, their Alexa, and their TV here with some Fire Stick or Chromecast, or it doesn't matter attached to it. Or just a smart TV, it's Roku TV. And they all get the same message, just like we were talking about with the hello world, and interpret it in their own specific way to get the message to the user. The user could then verbally answer the question and say, yes, I do want to see this. And that would be another PSYOP message that would be sent from whatever device is rigged to listen for it, back up to the cloud service, which could then send yet another message to the TV and show the zombie, right? So all of these interactions could happen, and we could actually get to a place where your Amazon Alexa and your Chromecast and your Nest and everything else could kind of talk to each other and interact. Plus, there's a separation layer here. So if this cloud software is no longer suiting my needs, I can substitute it and put in a different one. Any software would work as long as I hook those particular hardware elements up to it. So to make this work, we need to get the hardware to talk to that cloud service, right? So all of the pieces of hardware actually need to have their own client. It's a little bit of a bad analogy, but you can loosely think about this as a Java virtual machine. All Java virtual machines understand bytecode. They all know how to use bytecode on their hardware. If you have a Java virtual machine that works for ARM or Intel or whatnot, or Z, then you can run bytecode on that platform. This would abstract away on the protocol side. So if it understands the messages and it can receive them, it can then translate those messages into the actions it needs to do on that particular hardware. If it was that Braille machine, it would change the surface. If it's, say, a screen over there, it would manipulate the LCD to show the letters. So the other piece of this, though, is the hardware, in this case, needs to declare what interactions it can support. So if I have a device like that over there that has an LCD screen, it can probably show text, but that type of LCD screen in no way can show any real kind of graphics, right? So it's not going to declare that ability. It will say I can show English text, or I can show text in another language, but I don't have the ability to show graphics. So that manifest file would actually exist on the client side. And the software services would look for these manifest files and identify which pieces of hardware can be used for which interactions. And the software now kind of moves to, the software doesn't necessarily need to be a full application. It doesn't need necessarily a UI. It doesn't need to necessarily deal with input and output itself. It can concentrate on those interactions. Those are its new interfaces. Those are the way that it talks to the rest of the world, to other pieces of software and hardware and everything else. All it has to do is use that universal medium in which to get there. It also means that it's cloud-based. This is kind of key to it. The processing isn't done on the device. It's done off of the device. Now, this is something that will obviously not make it a legitimate solution for all situations. There are some times that we're just not going to be connected to the cloud. And it is possible that we could cache this, but I would argue that it probably goes against the basic paradigm of what we're setting up. Yes?
Well, couldn't it be a home cloud in which you actually set up a cloud at your home, and you have the device there and it does the communication, so no matter what you have, so rather than the whole cloud?
Yes, absolutely it could. Any network or way to communicate, honestly. And SIOP is more of an application level protocol. I was going to talk about that in a moment. But it's meant to sit on top of existing stacks. So it would be meant to work on the internet with TCP/IP, just like we're doing for most other things today. And you could network it in any number of ways. You could use UDP if TCP wasn't suiting your need, if you're doing video or whatnot, it doesn't matter. It's meant to sit on top of all of that, and you could absolutely use it in a whole network situation. So there's just 5 major kind of principles now I just want to talk about, because once you change this way of doing things, what we're doing is we're taking all those layers of the onion, all those other ways of abstracting, and we're saying we really don't need them anymore. And because of that, we're actually in a situation where we have to think a little bit differently about our software and our hardware and their relationships and how we actually set things up. So I kind of categorized a lot of that into these 5 principles, and some of this we've already kind of touched on, so I don't want to repeat myself too much, but some of it's already in here, but I want to kind of lay them out as broad-based approaches. So the first one is just where we left off. This is cloud-based, and I actually had in here hardware is primarily responsible for its interaction implementation, because there is the possibility you could cache, there is the possibility you could do a local network communication, but on its core, that is the hardware's primary responsibility, and it also means that it doesn't need any additional hardware, right? Because what it's doing, all it needs is a TCP/IP stack, which it probably would have had anyway. On top of that, it just needs to know how to receive a SIOP message, parse it, respond to it. That's not expensive. And it needs to know how to translate that information into action with its own hardware, which it had to do anyway. So the hardware piece of this does not grow any larger, right? It stays about the same. The services, though, they change a lot. we talk a lot about things like microservices today, and before that it was service-oriented architecture, and we refer to it as modularity, and we have all these terms, right, for making software so that we don't repeat ourselves. This offers a really interesting approach to that, because technically software services could all talk to each other using SIOP, and you could kind of build off of that if you wanted to, and build up, where you had a more modular approach. I think on the software side, more than even the hardware side, this has a real kind of profound effect on how we think about software. Semantic IO, as I mentioned, this is the problem I'm trying to solve right now. How do you categorize all input and output? I mean, if you think about it, there's quite a range of things we can do with computers, right? I can make gestures, a computer can actually be monitoring me and my movements, my voice, just video in and out, text-based, that can be typing. There's lots of ways that we can interact with computers, and we need a way to efficiently categorize that and put it into a spec sheet so that when I'm a hardware implementator and I'm actually building a client for this, I can pick and choose which ones I want to utilize, right? And then know how to implement those. So we need a universal way to actually transmit this information, and that's where this comes in. David Jennings, who is a student I worked with last semester, was working with me on this for his honors thesis. He put forth a paper as part of that last semester. And from that, we came up with 5 basic areas. And this might change. This was, a first draft. It was the first kind of cut at this. But it was 5 high-level areas that we felt if we break I/O down, it can fit into text primitives, gestures and movements, audio and visual. We also envisioned a second tier to this, just like an internet MIME type or a media type. It was a subcategory, right? So you don't just say that you're communicating using text. You're communicating using a certain type of text. So it would be text, US English. Or you don't just say that I'm communicating using audio or visual, and visual could be a different encoding scheme, right? It could be MP4. So